Welcome to Math 11 in the AM. Delta here, coming to you live with Dr. Dre. Vitamin J and Dre. I'm Jay. Okay. Data in my life. Of course, we'll just flip through, but here's where it fits into the whole scheme of things. We're not going to worry about that. We'll just talk about some things. Okay. So, Dre, data. You've used the word data before? Numbers, right? Usually number information formatted in a special way, but it doesn't have to be numbers always. It could be descriptive stuff too. We'll stick to numbers in math class. Survey, okay, I think in order, it's a way to collect data. And unit pricing, thrown in here too. You know how like if you buy a 12 pack of Coca-Cola or something, let's say, might be on sale, it costs you $6.99 for a 12 pack. Plus, how much does it cost for one if you buy it that way? If you buy it from a machine, it's probably $2.25 or $2.50. You buy it in a 12 pack, and you divide it out. That's the unit pricing. The price for one unit pricing. Okay. I'm not even insult you with this. 59 or 58, which is bigger? Well, okay. Okay. Here's one, the D. 8.9% or 8.94%, which is bigger? Yeah. I'm not going to, okay, add we're going to use calculators, so we don't need to have that. We'll talk it up, though. How many extracurricular activities in and out of school are you involved in? You? Zero. Okay, well, that's easy. List all the activities. Done. Zero. The number of hours per week. Okay. Well, I figured that. Didn't see you on the basketball team or the volleyball. Collecting data, but do you get the idea? Asking questions, and then you take this all down. But if you did that to 30 people and you just wrote down the answers, it'd be really hard to organize. You have like written little sentences. This is why it's easier to just go with straight up numbers, yes, no. You say 5 people out of 20 are on the volleyball team or something. So, numeric data, age, number of brothers and sisters, siblings. Non-numeric, the mode of transportation, car, bus, bicycle, foot, you know. Favorite food or color, okay. Those are non-numbers, and you can collect that. You can do a pool of data. Those too. It's the organizing we're going to focus on. Number of ways. You can graph them. Bar graphs, yep. Oh, yeah. I think it was being recording though what I have on my screen, so that was frozen. The bar graphs, I think you're familiar with that, right? Broken line graphs is where you have dots and then you just connect the lines. You'll see them. Histograms, they look like bar graphs, but the things touch, and there's a reason why. We'll talk about this. Stem and leaf plot. Not a huge fan of those. And then the circle graphs are pie graphs, like slices of pie. We talked about those already, though. Remember, which did you prefer? I think you guys like bar graphs better. Talk to you about the stem and leaf plot, how to understand them. Honestly, though, I've only seen them in math classes. I've never seen them in the newspaper or something like that, or other than a map. But it actually makes sense. I don't see it. So this is the marks. Here's what it is, though. 50, the marks. You got a mark of 51. You got a mark of 59. But instead of writing 51, comma 59, you just say 50 and then 1, 50, and 9. So the marks in the 80s were 81, 82, 84, and 88. You see how that works? Now, at a quick glance, you can see that 8 people real quickly got in the 70s. Right? That's where most of the marks. This is the same information in the circle graph. Let's take a look at that. Okay, you can tell by the slice of the pie that in the 70s and in the 80s, that's where you got the biggest slices of pie. You get the same information, but actually there's less specific information in the circle graph broken up into pie slices. And the other way, you actually knew what the exact marks were, which is fine if it's small. Like that's only 8 things in the 70s. But if you had hundreds of people taking this test, like this is a school-wide survey, you would not want to list 600 different marks like that. So you have a large number of data, you definitely want a circle graph or a bar graph. You know how to read one of these though? Yeah. Okay. Obviously, the bigger it is, the more. In bar graphs, now this bar graph doesn't have anything on the top or the bottom. It's just the marks. But they should have, you know, like student A and stuff like this. They should. I will, you know, you have Mark and Cynthia, Thomas, and stuff like this, A, B, C, D. One person got it. This isn't as accurate, is it? Can I tell if that's a 72 or a 73? Not very easily, right? Every once in a while, if it's right on the line, I can tell if it's like exactly. What I remember from the same number, that's a 51, but I only know that. Histogram. This is not a very good example of a histogram. Well, I guess so. But histograms, we say, I'm teaching with the workplace training guys, they should be touching because 50 through 59 is this high, and then the 60 through 60, it's touching that. Usually we have a touch like this, like fat bars. But since they don't show it that way, I won't insist that you do. Okay. How do we read one of these? Now let's tell a story with visuals rather than in words. Numbers. Help readers interpret information. This graph shows average home prices over 24 years in Saskatoon. Be similar in Regina. Okay. Turn of the century, turn of the century, I thought it was 2000, but 1990. Eventually we'll get to this. Back then you could buy more or less the average home was $76,000. You notice how slow that growth is for the first 15 years on this graph? 2005 here. It's just slowly increasing. And then boom, house prices jumped. 2007, right? And in 2013, 332. So that's what that tells you. House prices just go up and up and up and up. What information or trends can be interpreted from the graph above? You're going to write it in as we do it. Talk to me now. All ears. What can you tell from that graph? As what? Are the house prices increasing or decreasing over time? Increasing over time. Okay, got it. That's, yeah, jot that down. Prices are increasing over time. That's easily can tell that. Yeah. I'll give you a second to do that. And those of you listening to the recording can do that. Okay. What else? Well, one other message that can be interpreted. Well, they increased, I was mentioning, you see how they increased slowly until 2006, actually. Then the prices just jumped after 2007. Big price jump there. That's another one that can be. It really shows how the prices jumped between 2006 to 2007. It's so steep that 2006 to 7. huge jump in housing prices. I think there was a stock market thing happening then because I own the house then. Interest rates went down. Now, question 3 is what's a prediction you can make from the data? Predict. Well, obviously you'd predict, say, that's 2013. This is 10 years later, 23. What would you predict about house prices now? It's up there, yeah. Housing prices are most likely, the average house is definitely more than, what was that last one? 332,000. Just say that basically. Average house price is probably a lot more than. We can make that prediction. That is true. Okay. Let's see interpreting graphs here. Here's a pie graph, slices of pie in a circle. Energy bill for a single family home, approximately $2,200. 10 years ago? Wow. Oh, I see. Water heating. Okay. Okay. Reading that graph, yours is in color, isn't it too, on your paper? Where does the least amount of money go? Okay, electronics, yeah. DVD players and stuff. So write that down. And what's the percent of money that goes in there? Well, we're going to figure that out together. You know how to figure it out? 4%. Electronics. We take 4%, but I divide that by 100, I get 0.0. I say, well, that's out of $2,200. And we're going to need $88. That's a year. And I'll trust your numbers. That's everything. TVs and stuff don't actually burn a lot of energy and stuff compared to other things. The biggest category, 29%, is heating. That makes sense, especially in Saskatchewan. Second most is cooling. Where does, and then it asks for, oh, it didn't even ask for the, you know what? We figured something out that we didn't need to. What percent of the money? We just needed to say 4%. What percent? It didn't ask for the actual amount. Same with the next one here. Heating. We just need to read the graph. We went, that's 29%. The next thing, what percentage goes into heating and cooling put together? Well, that's 29 and the 17. So we just add those together. 39, 46%. Almost half of your budget is heating and cooling. God, I couldn't do easier. How about this? Data where you have sort of two graphs combined at the same time. You got average price increases compared to the average cost of the renovation. If you do your kitchen according to this graph, you see for every dollar you put in, it looks like approximately $2 back for the value of your home. So if you have a home, you want to sell it, and you spend, according to that, about $1,200 on your kitchen renovation. It's done nice and people like it. You potentially more than double your money when you sell the house. You'll ask that much more. Looks like about $2,800 extra. That's a good value. Painting your house exterior. See how the smaller one is, the average cost of painting your house is less than $1,000, and it has a return that's less than 2,000. So I'd say that's more about 17. That's a pretty good return on. And then it goes on home staging. That'd be if you're going to sell your house, you just get rid of all the junk and then you put in really good furniture and stuff like that. That's pretty cheap and it has a big payoff. Painting your interior walls. Cleaning and decluttering is always good. Repairing damaged floors, definitely a payoff. Landscaping. Update your bathroom. Not as big a payoff as the kitchen. Replacing carpets, shampooing carpets, yeah. Lightening and brightening. Repairing plumbing and updating electrical. Okay. Now, if you were to do a home renovation, I don't know where you live now. Let's just say there are two different reasons why you would do a home renovation. If you're going to renovate your home just to sell it at a better price, you might make different decisions if you're going to renovate your home because you want to live there for the next 10 years. Let's pretend you're going to stay at your home for 10 years. You own it. What would you do to your house out of all these different types of things? And why? Let's just go with the bathroom. It's a good one. Messed up. Okay, because you'd want to use it for a while. It would probably even sell better too. It probably, just from what maybe without seeing it and stuff, probably would sell better than if it was, if you own the home and you're going to sell it too. Right? Renovating a bathroom doesn't increase your resale price as much as some of the other things on that list too. So there's cheaper things you can do and get a better result. No, okay, this is an opinion. So you put down what you are thinking. Those of you listening, do that. Which home renovations would you be least likely to do and why? Think about this. Are there ones that you can't do or can do by yourself? Can you paint? Really? I think you could. Most people, given a few tips from somebody, a friend or something like this, you can do it cheaper because you could do it yourself. Typically, home renovations that you've got to hire somebody else to do might be lower on your list because it's going to cost you more. You pay for someone to do it, right? Plumbing, electrical. Usually those are things most people can't do themselves. Updating a kitchen, I pull homeowners permits and do that, plumbing, electrical, stuff like that. But updating a kitchen, it takes me a whole summer though. I've done kitchens over and stuff like this, but I mean it's like 2 months of, well, you do it in the summer because I'm a teacher. I have 2 months to do it, and I do it, and I can barbecue outside and stuff because I got no good oven and sink, and it's a mess in the house. So if you do a kitchen, for example, it really disrupts your life. You don't want to do that in January unless you have a place to go eat, stuff like that. There's all kinds of reasons. That's an opinion piece, and I just want a good answer. I'm going to whiz through these other ones in the next 3 minutes. Okay. Dr. Dre, I'm going to just talk about these ideas, and you'll be able to over the next few days. Not even a few days. What's the purpose of collecting data? Well, to make, some assumptions and stuff like this based on a large amount of, not just your own experience, but other people's. Different ways you've seen charts, graphs, all kinds of things. Why display the data? I'd say display it in graph and stuff is quicker to sometimes see trends and stuff. And answer these questions and ask me if you. Best way to display data, it depends on the data. Predictions, you can often make predictions. Decisions. And so data-driven decisions about home rentals. Look at this. You can buy a big 17-liter pail of paint or a 3.79, sort of a U.S. gallon of paint. Obviously, it's cheaper, but how much is it per liter? If you know you're going to use a lot, is it better to buy the big jug or the little one? In this case, I would go with the little one. Look at this. The cost per liter here is 12.89 cents per liter, and that's for the big thing. It is slightly cheaper than 12.92, $12.92. But that's not a lot different. You know what? I would go with the smaller ones, and here's why. If you ever paint, if you have a big thing, paint needs to be mixed and stuff like this, and it gets crusty on the outside. If you have a big thing, you're not doing it in a hurry, it's going to dry up and get crusty. You might spill stuff. Okay, exactly. So you know what I'm saying. If there's not a big price difference, if this stuff was a lot cheaper though, I would definitely go with the 5-gallon, or the 5-gallon pail, the 17-liter pail. If it was significantly cheaper, and I do check those kind of things. Actually, I'm painting a house right now, and I'm buying 5-gallon things because it's almost like the 5th gallon is free, almost. So you know what I'm talking about. Okay. And then you're done. This is a pretty easy one.